Welcome back. In previous lecture, we set stage for exploring Docker and containerization. But before jumping into Docker, it's absolutely important to understand why exactly do we need containers. Virtual machine VMs has been central to deploying applications and infrastructure for a decade. They help immensely in improving hardware utilization and managing isolation and security, and they are great. But this VMs brings its own set of problems and challenges, and these problems motivated creation of containers. So in this lecture, we will take a closer look at these VMs issues so that we have solid foundation for understanding why containers is so transformative. First, let's have quick revision on what is virtual machine so we all are on the same page. What is virtual machine? Virtual machine is isolated computing environment created by abstracting resources from physical machine. Well, let's decode this. So, virtual machines are isolated computing environment from where? From physical machine. Let's imagine this is our physical machine. So, this physical machines has the some resources. Okay, let's assume this physical machine has 128 GB memory and 32 core CPU. Now this physical machine has the resources, right? So what definition is saying? Definition is saying, so virtual machine is isolated computing environment that is created by abstracting resources. What is resources? So if this is the physical machine, right? From where? From the physical machine. So if this is the physical machine and this physical machine has, this is the resources, right? 128 GB memory, 32 core CPU, then this virtual machine abstract resources from the physical machine, then this is create a virtual machine. Now how does it do that? This do with help of a tool called hypervisor. Now again understand this. So if this is the physical machine, so what happened on top of this physical machine hypervisor, this software sits and it let you divide it, this physical server, into a small virtual server, and this called virtual machine. So what we see, we have this physical server. On top of this physical server we have the hypervisor, and this hypervisor dividing this physical server into four small virtual server, and these small virtual servers called the virtual machine. And we have already understood this in the AWS section, but just I wanted to make sure you remember this and we are on the same page. Now let me give you very simple example. So let's imagine you have a laptop and this is the Linux operating system. Now imagine if you need to test a window application or maybe a window software, how you can do that? For that you can use a virtual box tool. So I have been using this a lot in my college time, so if you are aware then it help you to understand. So using this virtual box tool or maybe genome boxes or maybe kvm, what you can do, you can create a virtual box inside your computer, and these are completely isolated computer inside your computer, and it's run completely independent of your laptop. So this is simple example of virtual machine. Now question comes, why do we need this virtual machine? Now let's understand this with the example. So as I said earlier, we had a physical server. So let's say this is the physical server, and here a company need to run a application. So what they can do, they can go ahead and buy a physical server. And again imagine if this physical server had capacity of 128 GB memory and 32 32 CPU core. And if they are assuming when they make this application, let's say we have this application live, so on normal day they will have traffic around 100,000, and on the peak day, so when they have less the sales day, good friday, festival times, maybe new year, they will have 1 million traffic. Now they have to go and buy these physical servers that has capacity to run a traffic of 100,000 in the normal day, and also that has enough capacity to run 1 million users on the peak days, right? So here they have to go buy this physical server that able to serve 1 million request, 1 million traffic, right? So having keeping this in mind, they have to buy a server with the bigger capacity, right? So these servers are expensive. Imagine, right? So here in your normal day you have only 100,000 requests, but in the peak days, let's say in the year 15 days, maybe in a year 20 days, if they have 1 million traffic, right, then they have to buy a bigger server, right? So those server able to sustain all the traffic of 1 million, right? So they are buying the bigger server, and so these are expensive, right? What is the second problem? Second problem is the wastage of resources. Now you already understood this point as well, right? So here means around in the 365 days, only if 20 days we have the peak days where we need to serve 1 million traffic, right? So remaining 335 days, 45 days, right, this servers going to sit idle. And this is the reality. In as per the statistics, around 90 to 95% of physical server remain idle, and we waste the resources. Now next problem with this physical server is security and isolation. So what happened, as you notice, around 90 to 95% of this capacity of these physical servers remaining idle. So people started finding some way to run multiple application on this physical server. So if application has the same operating system, okay, so they thought maybe they can run two application here. That's what they have started doing. But now when you are running two applications from the same physical server, so you are sharing the resources, this application accessing also this application files and all, right? There's no very separate isolation, so this creates security and isolation issues. So these were the three region, and there could be the many region as well, to think about how do we create a isolated server, isolated machine out of these physical server. That's why virtual machine came into the existence. Now you see this physical server using the hypervisor, we are creating a small virtual server, and this is called virtual machine. And good part is that this is completely independent of each other, and each will have its own operating system. So this virtual machine could have the Linux operating system, this could have the Windows, this could have the Mac OS, and this could have again Linux with the different distribution. So this is beauty of virtual machine. So they are completely isolated, they could have the different operating system. Now we are going to use this all those resources, right, for the four different application. But these are really good, they're working really well, but it has its own set of challenges. Now let's understand what are different challenges with this virtual machine. First problem is slow startup. Yes. Now let me give you a very simple example. So when you start your laptop, how many minutes it takes? Maybe around 2 to 3 minutes, right? Similar. when we go and start a virtual machine, it takes 2 to 3 minutes. And when on top of this virtual machine, when you go and install some software, and all those software also need to be started, let's say Nginx, your application, right? So it takes additional minutes. So all together, this is, let's say if this is 3 minutes, then plus one, this is 4 minutes, right? And this is huge time when you are running a application in auto scaling, and auto scaling creating the new virtual machine, and this virtual machine taking 4 minutes to up and running. So this is huge time. By the time your user will go away and they will get the error. So this is problem with the virtual machine. And when I'm saying this is 4 to 5 minutes, and this is really sometime even it takes 5 to 8 minutes. I have seen some virtual machine takes around 15 to 20 minutes. Again, depends on what you have on this virtual machine. People use antivirus, people use different security tools, right? So all those start scanning the virtual machine. This takes a lot of time. So this is problem with the virtual machine, slow startup. Next problem is large OS overhead. Yes, let's understand this with very simple example. Take example of our book review application. And book review application, we had our front end, right? And this front end, we were running our application, and that application was using Next.js, right? And to run this application, what do we need? We need the Node.js, right? So to Node.js, basically it will need maximum 200 MB of memory. But to run this front-end application on Node.js that needs 200 MB of memory, what do we need? We need a operating system, right? And we have been using Ubuntu for that. And to run a Ubuntu, how much memory do we need? Go ahead, search on the Google. It will need around 1.5 to 2 GB of memory. Now imagine, right, to run a application that technically needs 200 MB of memory. For that we have a operating system that needs 2 GB of memory, right? So here you see large OS overhead. Now if you multiply this, imagine if you have the 100 virtual machines, right? Now imagine how much memory going for the operating system and how much memory really needed for your application. So this is one of the another big problem. Next problem is efficient resource utilization. Again, this is quite related to the previous point. Okay, so again, let's take same example. Imagine we have again our book review front-end application, and this front-end application, we understood for the Node.js we need 200 MB of memory, right? But for the operating system we need around 2 GB memory. Now when you are going and running this application in production, right, so you need at least 3 GB of memory, right? But if I could be you, right, I need to run this application in the production, so maybe I will go with 4 GB of memory to make sure my application should not have the slowness. Okay, there should not be the issues when application getting started, right? So I make sure it has really good enough memory, right? So you are using 4 GB memory. But imagine again for our running our real application, how much memory do we need? We need 200 MB. So in technically, okay, it's fine, we can go ahead give additional maybe 500 MB, right? But imagine 200 to 4 GB is huge, right? So again, virtual machine is inefficient in the resource utilization. Now next problem is portability, and this is one of the biggest problem with the virtual machine. Now let's understand this with the example. Imagine there is the developer, and this developer developing our front-end application, right? Now developer has the operating system, let's say Ubuntu 22 version, right? Then to develop this application, of course, he had the Node.js, correct? And he used, let's say, latest version. And again, there is different dependencies and libraries that what he need to install for our different part of our application and component, correct? Now, once he done the development, then he need to send this application to the tester, and she is testing the application. And here, let's imagine if she is using Ubuntu 24 and she's also testing different application. So she has different, okay, she has the all libraries and dependencies what we need for this application, but she has the different version, right? So you see here, so this create the portability problem. So application that was completely running fine over here, when it will go on the different person computer which has the different operating system, even if the same operating system, but this libraries has the different version, so this is going to create the portability problem. This application is not going to run as it is, and this is running on this machine. So that is another biggest problem. And here I'm giving just simple example of testing, right? But this happen more often in the production. What happened? Different teams works on their local machines. They develop the application, and each one has the different operating system, different dependencies, and somehow they fix and they make application working. But once this application go on production, then people says it's working on my machine, application is working on my machine, there is defect in the production. And this is the meme used inside the industry a lot, and they are not wrong because they have made everything working on their machine, but when it's going on to the production, so production has again a different operating system, different libraries. When you are downloading phrase, right, it's getting mixed up, and they are saying this problem with the defect. So what is the solution? Again, this another meme you can see on the internet. People say, okay, if this is works on your computer, no problem, then we will ship your computer on the production, or maybe then you ship your computer, give me your computer to me, right? So that's where Docker come into the picture. In Docker, what happened, I mean not Docker, in container. So what happened in containerization world, we packaged everything together and send it to the different person or maybe different environment, so it goes all together. Okay, so it's literally mean shipping your computer. Don't worry, this is what we are going to understand in next session, how container works. Perfect. So that's pretty much I wanted to cover in this session. Thank you so much. See you in the next session.